Hello and welcome to our live feedback video. Delighted that the whole team can join us. Keep your questions coming in through the Google Hangouts page. You will need a Google account to ask the questions. Or you can go to Twitter using the hashtag #XClimateLive. Ask them on Facebook, we're facebook.com/climateexeter, or on the Future Learn discussion panels. The whole team are here ready to answer all your questions. So, start with Tim, what was your highlight of the MOOC?
Oh, that is a tricky one. I really just enjoyed seeing the amount of engagement on the platform and the good stream of questions coming in. And I love some of your blogs were fantastic, by the way, as well. So,
Damien?
Yeah, hearing all your stories, all your interpretations of some of the things we were talking about, and your local examples from all over the world it's been really exciting. And seeing Liam put them together on a map and compare them, it's great.
Anna, you were big on the ocean acidification. Was that your highlight?
Well, it's what I do in my PhD, and I love discussing it with everybody on the MOOC as well. So yeah, I guess so.
Yeah.
What about you, Liam?
What about me? My personal favourite, probably the cryosphere section.
That was my least favourite.
Oh, really?
Shut down.
I found the ice really, really difficult.
No, it's great. It's great fun.
don't worry, it's all melting.
Well, that's my first question. First question comes in from Ron. It's a two-parter. Which major tipping points do you think might occur first, and which should we worry about the most?
Whoa, tricky question, Ron. This is your question, isn't it?
Unfortunately, we could be past a couple of ice sheet tipping points. Certainly, there's a lot of discussion about loss of part of the West Antarctic ice sheet, the bit that drains into a place called Pine Island Bay. The altitude of the ice there looks to be dropping at an alarming rate, and it looks like a thing called the grounding line, where the ice and the water and the bedrock come together, is retreating there. And then the question becomes whether, if you lose that bit of the West Antarctic ice sheet, which already drains about 1.3 meters of sea level rise, whether, because of the physics, if you lose that bit, the other bits will eventually go. And some of the models say they would. So that's a big concern. My glaciologist friends also tell me they can't rule out that they can't really say whether Greenland's going to stabilise or not if it retreats up onto the land as it seems to be doing. We probably can't rule out that it might just carry on shrinking. The only comfort there is that these ice sheet loss rates are fairly slow at the moment. But Damien's the expert on the glaciology.
Yeah, in terms of West Antarctic ice sheet tipping point and the Greenland ice sheet tipping point, in terms of overall sea level rise contributions, then the Greenland ice sheet has much larger sea level rise potential. But that's not to say that all of it will disappear if you have collapse, because as Tim's mentioned, you might have a smaller inland version of smaller ice caps. The West Antarctic ice sheet is sat on bed beneath sea level, so it's already offset some of that sea level rise potential. So the overall amount, if both of them were to disappear completely, then Greenland would have the largest impact on sea level rise. And in terms of impact, what we should be worried about, it all depends on your idea of timescales and what's relevant to you. Like Tim said, we may have gone past the tipping point already. We might be irreversible. We might not be able to recover collapse, but this collapse isn't just going to be like a building falling down. It's going to happen over many hundreds, maybe thousands of years.
So in terms of things that can happen a bit faster in the climate system, our models are saying that the frequency of extreme El Nino and also the extreme La Nina events will double if we carry on the business as usual trajectory this century. And of course, we're kind of in the midst of quite a strong El Nino at the moment, so that's kind of a warning of there might be more to come. The other thing that really concerns me is the observed weakening of the Atlantic Ocean's overturning circulation is really quite strong. Whether that's natural variability or not, we simply don't know, because we've only been monitoring it for 10 years. But it's strong enough that it's left there's one part of the planet that isn't warming up, if you like, and it's like a cooling hole to the south of Greenland, and that's because the heat transport by the Atlantic overturning has slowed down so much that it's outweighing the warming signal there. That would be a huge concern if that weakening trend continues, because it drags the band of rainfall around the tropics, called the intertropical convergence zone, southwards, when you have less Atlantic Ocean heat transport northwards, and that amounts to weakening the monsoons in West Africa and in India, which is a big deal for not just millions but billions of people.
Yeah, that's kind of been the subject of some Hollywood films, like The Day After Tomorrow, shutting down of.
Yeah, but weirdly, of course, because they're made in Hollywood and they're mostly screened to rich viewers in the Northern Hemisphere, they concentrated on this sort of horror story of a really icy freeze up like another ice age, which isn't really what our models predict at all. No, the big story, if there is this week, I think, if there is a big weakening of the overturning, would actually be these unfolding ramifications in the tropics. Although it would alter the seasons very radically in the UK, for example, it would make the winters a lot harsher relative to the summer. Yeah.
Okay, so our second question comes in from Anna. She asks, what's the role of solar activity in climate change? How much of the climate change that we're seeing at the moment can we put down to natural variability in the sun?
Actually, relatively little when you look at it in terms of this thing we call radiative forcing, the changes in watts per meter squared coming into the lower atmosphere. So, and if anything, the solar activity is becoming more quiescent at the moment. So it ought to be cooling things down, and it definitely isn't. It might have played some role, the decline in solar activity in the recent so-called warming hiatus or slowdown of warming. But rapid warming is just in the process of resuming at the moment over the last year. So we don't, in our models, we don't see it's in there as one of the several drivers, but it gets swamped out by bigger trends. In a recent Earth history, it's got some role to play though, for example, probably in the so-called Little Ice Age for Europe, when there was a historic minimum in solar activity. And it's kind of intuitive that any changes in solar activity would matter, because obviously the sun is the big one and only heat source for the climate.
Yeah.
So it's we for that reason we and others study it pretty carefully. So we have a pretty good understanding, I think, of that.
What about sunspots on a shorter time scale?
Yeah, so the 11-year sunspot cycle seems to have a potential to influence, well, it has some influence on the climate, and it's still being untangled how that plays out. So we have some experts here in Exeter on how the Earth's stratosphere interacts with the lower atmosphere and the troposphere, and how the solar activity might influence the lower atmosphere via affecting the stratosphere and stratospheric wind patterns, for example. So that's kind of interesting ongoing science. But yeah, it's in there in the models as one of the many drivers. Yeah.
So my next question is, I guess, for Anna. There are a few coming in live about ocean acidification. Firstly, how do we measure ocean pH?
I think Tim knows a fair bit about that.
You're going to duck the question.
I know. I would take my pH probe and stick it in the water, and it gives me a pH reading.
Straightforward pH probe.
Yeah, that's what I would do. But I know that people go out on cruises, ships, they deploy.
You can do it old school, with various colour titrations, so chemistry basically, or the famous sort of litmus type paper tests even. So yeah, you can you can do it the old school way as well if you want.
And I suppose, which areas are most at risk of ocean acidification? Or maybe extrapolate that, which species, what are we most worried about when we talk about ocean acidification?
I know that there are some ocean acidification hotspots where it's occurring much more rapidly than in other places.
So the Arctic is really
the Southern Ocean.
So if we remember how maybe in the course at one point, folks, we were chatting about if you heat your glass of carbonated drink up, it bubbles out its CO2, which is the carbonation. Conversely, if you cool your carbonated drink down, it holds more CO2. Now, for the same reasons, the Arctic dissolves more carbon dioxide because it's colder water, as would the Southern Ocean. And those are the places, therefore, that reach what we call the saturation points for different specific minerals first, because they're kind of they acidify the most and the most quickly. So it actually means that the calcifying organisms in the Arctic and possibly the Southern Ocean regions will probably be faced with the biggest chemical challenge. But as we talked a bit about on the course, and we were talking about this with Kerry, weren't we? Of course, there's great pH challenges for organisms that live near shore and get influenced by river inflows and such like as well. So they've adapted to that. But yeah, we're worried. I think we're worried in particular about some more polar calcifying species.
It's worrying.
Plenty to worry about.
Plenty to worry about with climate change.
Reasons to be cheerful, presumably, as well.
So moving away a little bit from the physical science, I'm sure we'll come back to it eventually. What's everyone's thoughts on nuclear? Should we go nuclear? Is there room for nuclear? Would you want a nuclear power plant on your back garden?
I know that when we were looking into kind of ways that we could combat climate change, your 2050 kind of, where you could simulate what you would do, that without nuclear it was really difficult to make any observable change. You know, it needed to be part of something that was going to reach the target sooner.
Well, and there's a big global energy assessment led by colleagues at the thing called the International Institute for Applied Systems Analysis, which is a mouthful, outside Vienna, IATA. Big report, a bit like the Intergovernmental Panel on Climate Change reports. And indeed, you're absolutely right. Nuclear is usually in the mix for a low carbon energy future. But historically, with the exception of France, nuclear energy for electricity has struggled to get more than about a sort of 10 to 20% foothold into the energy mix in any country. France, partly because they had very few of their own fossil fuel reserves, went for it and have got, like, I don't know, roughly 80% nuclear electricity supply, and are actually now, having made the large capital investment to do that, are actually reaping the benefits and sometimes able to sell their nuclear electricity across borders in Europe. But what's always been the case is nuclear has been relatively expensive, unfortunately, compared to fossil fuels, for example, for the same energy generation. Or even now it could be outcompeted by wind and quite soon by solar PV in places. So part of the cost of nuclear is, of course, socially constructed and about how we handle or don't handle the waste. But yeah, I'm fine with nuclear personally, but I realise it's not cheap. So there's a certain economics to this.
Is there anything we can do with the waste? Can we make energy from it?
Well, this gets into the difficult territory of what's called breeder reactors. So in principle, you can have a nuclear energy system which does kind of recycling of its own waste, but that's called a breeder reactor, and that tends to produce weapons-grade fissionable material along the way. So it's very hard to disentangle the kind of recycling-based nuclear civil energy program from the issues around proliferation of nuclear weaponry. So they're not always entangled, and they don't have to be entangled, but they do become entangled, weirdly, if you go towards more of a recycling type of system. So a lot of the move has been because of that concern that we're all concerned about. We've all been concerned over my whole life probably about nuclear war threats, that interest has shifted more to things like thorium-based reactors and pebble bed reactors, and so it's almost like lower tech, but yeah, just slightly different nuclear fuels. And a thorium-based reactor system is not. The good thing about that is it's never going to make you some fissionable material that's some sort of potential geopolitical threat. But still, cost. Can we get it cheaper? And cost is partly controlled by how much does society invest in research and development and so forth. And that varies radically across technologies as well. So it's never really a level playing field. But
That's true.
yeah.
Damien, one of your research areas is in GIS and remote sensing, how we can use remote sensing to monitor the Earth's climate, for example. There's a question here about how can we model when certain areas will be flooded? So can we use topographic detail to model flooding situations? And sort of extrapolating from that, how is satellite data being used to monitor the Earth's climate?
Wow, big questions put together. So how is remote sensing data being used to look at climate change? Well, in order to in all our global climate models, Tim's discussed them already, and we looked at the forecasts we make in earlier on in Peter Cox's week. You need input data, you need observations, you need data, sea surface temperature data, land data, and you can get that by using remote sensing, using satellite imagery to actually look down at the Earth and make measurements remotely, so without physical contact. And that ability has actually allowed us to answer and question some of the things that we had in the climate. So like identifying the ozone hole in Antarctica, for example, from satellite observations. So now for global climate models, something like 50% of the input observations can only be observed from space, and the remaining observables, a big proportion of those are also observed using remote sensing. So yeah, by taking measurements of across the globe, we can get an understanding of changes that feed into these models. So that's how remote sensing plays a big part. And the first half of the question?
How we can model whether certain areas will be flooded. So
right.
Is there enough topographic detail to know that?
Yeah, the laser artillery is really, really good now. Yeah.
Yeah, so topographic mapping, topographic data, getting an idea of changes in the elevation of the land. And we can do that from, as Tim said, from laser altimetry. So we send a LiDAR, light detection and ranging, which sends down a laser beam and records the time travel for that laser to hit the Earth and go back to the sensor, whether that be on a satellite or a plane, or more commonly on different applications. And so, because you know the speed of light, you can work out the distance between the sensor and the land, and therefore the changes in elevation. And then you can use that topographic data set to simulate changes in rainfall patterns, or in the case of sea level rise, in order to actually to make these predictions. If you have a meter sea level rise, what areas are going to be flooded? Of course, there's some complications in that, because as and we're talking about global sea level, has regional sea level differences due to land subsidence, due to different gravity anomalies. But yeah, the topographic data needs to be in there, so you can identify these low level lands and see where that water will go.
Cool. Anna, in your research, do you use any sort of satellite data? Can it be used to monitor the oceans?
Well, it does get used quite extensively, but not in my specific area, which is looking at the fertilization ecology of marine invertebrates in response to ocean acidification.
It was a long shot, yeah.
So, but I know that it's a huge kind of area, and quite locally to here, Plymouth Marine Labs, they do a lot of modelling. They've got a really cool remote sensing system, use a lot of the data.
Yeah, there's real excitement now there. The latest technology that's hopefully going on the International Space Station and the satellites allows you to look in detail across different wavelengths of the spectrum of light. And using that, we not only ought to be able to literally see the difference in colours and therefore species of different trees in, say, tropical forests, but potentially we'll be able to eke out more information about the different types of plankton living in the surface ocean, because we know about their different pigments of light absorption. And the technology should become good enough to really get a better sense of the biodiversity, if you like, in these surface waters as well as on the land from space, which is an extraordinary thought, I think. Yeah.
Just an update, if you've just joined before, after we started, sorry, keep your questions coming in on the hashtag #XClimateLive on Twitter, via the Facebook page, facebook.com/climateexeter, or on any of the Future Learn steps. We've got Alex and Josh behind the scenes looking at all your questions, handing them to us.
Let's show you guys what they're up to. Here they are.
Hey, there they are.
Okay, sticking with the biosphere a bit, we've got one from Maritza. Is the terrestrial biosphere changing from a carbon sink to a carbon source?
Let's hope not, Maritza. Not at the moment, although it might. Well, I say that, but actually the one time when the terrestrial carbon sink has historically been wiped out was when we had a really strong El Nino event in 1998. And now we're just in the middle of another strong one. So it's possible that this El Nino will kind of eliminate what's usually a pretty healthy 2.5 or 3 billion tons of carbon per year land carbon sink. If you're wondering how it does that, it's because the pattern of heating affects particular areas of tropical forests, and it causes both anomalous fires, for example, Indonesia, classic case, in point. So you get all this extra carbon being burnt off literally in fires. And you also get drying typically over the Amazon, which leads to some tree death and also just stronger net respiration, net return of carbon dioxide to the atmosphere from plants and soil respiration. And it's really, an El Nino is a really big El Nino is enough to turn the tables around by like 3 billion tons of carbon per year and leave the land kind of net nothing really, neither a sink nor a source. Although maybe this El Nino event, when we look at it retrospectively, will turn out to be the first where it turned the land into a carbon source. That would be a striking result if it turns out that way. If we look further ahead and we just look at the overall warming signal and how that has the potential to weaken the carbon sink on land, well, that's kind of in competition with the fact that the extra carbon dioxide fertilizes the vegetation. But there's that so-called CO2 fertilization effect. It's kind of a saturating effect. You get less and less bang for your buck as you push the CO2 up. Whereas the temperature effects on respiration, they're like exponential curves. They get almost more and more potent as the temperature goes up. So you kind of expect the temperature effects to overtake the CO2 fertilization at some point. And it depends a little bit on the models, but if we go into, say, a 4 degree warmer world later this century, then certainly in several models that would kind of turn the land from a sink to either neutral or a possible source. So it's kind of watch that space, because right now the land and its ecosystems are our friend. They're really playing a big role in slowing CO2 rise and climate change. So we really don't want them to turn tide and start adding to the problem.
It looks like we've got a comment coming in from Colin, asking about us facilitators. What are we going to do when we all have our PhDs? So, Anna and Josh, I guess you're the next people to get your PhDs.
Anna's first.
Nearly there. 4 years kind of approaching rapidly. Well, I'd like to continue on in marine-related research. And once you kind of get yourself down an area of research, you've got to keep going. That is my area. That's my specialisation. So I'm going to continue in the climate change, marine-related research field. Hopefully, I'll be giving talks around the world, and, which I'm
producing your own food.
producing my own.
So yeah, probably mine shot.
Josh,
Come round.
Josh, there you are now.
So yeah, I'm going to be doing a PhD starting in September, looking at the controls on ice discharge on the Greenland Ice Sheet. So hopefully looking to address one of these key sort of tipping point areas that we've been studying in this course. So hopefully you should find some really interesting results that can be communicated effectively on a public level because of their sort of relationship to sea level rise.
And Liam, you're still an undergraduate, but are you feeling tempted by research?
After uni, I'd quite like to do a master's in remote sensing. So carry on looking at how new technologies can be used to research climate change. So researching the research, I guess.
Alexandra, what about you? You
Tony.
can point the camera at yourself.
I haven't thought about it much yet, but more environmental and sustainability research, I think.
Yeah, there's plenty to do. It doesn't have to be research, does it? Like, there's so, as we've learned on the course, there's so much to do in this whole space as a society that you can make a contribution in pretty much any walk of life or work, I think. Yeah.
Damon, we're coming back to you for the next one. What are the latest Antarctic sea level predictions? So we've got someone saying, someone's asked, is it only 10 centimetres by 2100? Is 10 centimetres nothing?
That's not nothing though. That's
10 centimetres doesn't sound like very much, but if you can combine that like with storm surges, so small sea level rise. I mean, this is globally, right? So actually, it's a lot of mass loss just to get that little increase. But yeah, combine that with a high tide, spring tide, and a storm surge, and the winds and going in the right direction, you have some of the flooding that we experienced in like January 2014. The reason why I kind of sniggered at that correct question is because there's still massive uncertainty in answering that. Definitely the West Antarctic ice sheet is the most vulnerable. We've talked about that in terms of tipping point. The East Antarctic ice sheet is probably the only, well, Tim might be able to correct me, but maybe the only natural way that we can offset any sea level rise. Increase in precipitation if you've got a warmer atmosphere might actually increase the mass. So that could actually offset some, but there's still a large uncertainty about that because we're likely to have more melt around the margins of increased carbon.
Yeah, exactly.
So yeah, getting those predictions is difficult, so I'm going to stay away from giving you an answer in terms of the amount of order equivalent or anything like that. Tim?
Yeah. You spoke about increasing the size of the East Antarctic ice sheet. There was a bit of confusion in week 5 when you spoke about, so the centre of Greenland is actually seeing sort of an increase in accumulation. So more snow, more ice in the centre of Greenland. Is it just coming up onto our land? Is there anything to worry about there?
It's Damien's topic as well, really. But there's this general trend that a warmer world is a wetter world with more precipitation, and if it's cold enough, that precipitation will fall as snow, and that would be the case in some of the data for Greenland. But at the moment, for Greenland, any extra snowfall inputs being outweighed by extra melt on the surface and extra carving of glaciers off the edge. In East Antarctica is really interesting because in some models there was that possibility that you'd have the extra snowfall and it would, as Damien was saying, you could potentially build up the ice dome. The trouble is the most recent work is looking around the periphery and spotting that bits of the edge of East Antarctica behave a lot like West Antarctica. They have the bits of the ice sheet grounded below sea level with the possibility of grounding line retreat. There's one basin in particular, Wilt, I think it might be, that has about 3 or 4 meters of sea level rise, and it's all held back by just a very modest ice shelf, ice plug. So unfortunately, the more we look, the more we discover these possible contributors to the sea level rise story. What we didn't talk about in the course, which might interest the participants, is that the sea level rise that comes from ice sheet loss isn't globally uniform. So the changes in what's called the Earth's geoid, or a sort of gravity, if you like, that happen when you lose an ice sheet actually affect where they kind of redistribute the sea level height and have different effects around the world. In essence, the biggest effects on sea level are furthest away from the ice sheet you're losing. So when we talk about Antarctica, there'll be a relatively larger than global mean contribution to sea level rise on the opposite side of the planet, namely up where we are in the high northern latitudes. Whereas for Greenland, around the immediate surrounding of Greenland, actually the gravity effect outweighs the extra sea level, and if anything, there's kind of no effect, and it's further afield that you get these larger effects. So those factors have to be brought into the mix. And that's exactly what we do in these kind of future projections and models.
We've had a very interesting one. If we all had $1 billion to invest to combat climate change, which area would we choose?
That's a great question.
So I think personally, if you've only got 1 billion, there'll have to be a sort of mitigation, adaptation techniques. So mitigating against or looking into how we can stop the effects of climate change being so severe.
I'd spend my billion on protecting and restoring tropical forests, because at the current price estimate, something like $5 per ton of carbon or less might be down it might be as low as $1 a ton of carbon. So I can probably turn that $1 billion dollars in potentially into 1 billion tons of carbon, or a gigaton of carbon restored into tropical forests, and then they would keep taking it up. So if we could just protect very productive forest regions from the degradation they've had and some of the deforestation they've had, and put them into permanent secure reserves, we could really just let those ecosystems do their bit to be a part of the land carbon sink. And on all the current cost estimates, that's probably, you get your biggest bang for your buck with that, I think. So it's a form of carbon dioxide removal, but nature's doing the work for you. Very low tech, but great for biodiversity. Do it right. Make sure some of that revenue, the carbon credits, flow to the local communities, the indigenous people of the forest, and everyone's a winner then. They've got an incentive to help protect the forest, biodiversity's coming back, and the carbon cycle and the climate give a benefit.
What do you spend your $1 billion on?
Well, I like Tim's option, but I'd be quite cheeky, and I'd use the money to get my candidate into government as president and as prime minister of all the important countries around the world.
Interesting.
So get my representative into America, Australia, China, rule the world.
Yeah, I think you could use that money, as you both said, to try and mitigate that. But I think as well, we've got to be looking at changing our energy resources, because we can't just keep going as business as usual. We need to be changing the way we create our energy. I don't know if $1 billion would go very far though in that area. So yeah, it's a tough one.
It really depends on what I call the technology readiness level, or how mature a technology is. If it's an emerging technology, it can make a really big difference to try and see whether it can be brought up to scale. But I think it's a great answer, because what we know about in the energy system is we actually have some almost pretty much mature technologies that we just like to keep on getting cheaper, like solar photovoltaic cells, and roll them out. So we actually know what the technology is there, ironically. It's just incentivizing it.
Yeah,
but your $1 billion can go quite a long way in shifting the incentives and the subsidy regime. Yeah.
Next question is about how we take action for this week, about some of the solutions to climate change. What can we do as citizens to reduce our carbon emissions, and what are you guys doing already? So you mentioned putting insulation in your loft recently.
I have, yeah. I've got a flat-roofed house, which is a bit quirky in Devon because it rains a lot. But yeah, the flat roof is now raised considerably by a nice big wodge of extra insulation. And the house is really, quite well double glazed, and made it pretty energy efficient, I think. I'm fairly happy with that. But when you look at your own carbon footprint, and you're an academic who gets invited to international meetings, you see that it can easily be swamped out by your international travel. So I've been trying to persuade some of the people inviting me to give talks to let me do them virtually, so that we cut the carbon emissions of the travel. I've had some success with that. I think there's a cultural change needed there. But yeah, I have a car, but it does less than 6,000 miles or 10,000 kilometers a year for 4 of us. So I hope that's fairly under control, and it's quite fuel efficient. But in my ideal world, I'd probably go for an electric vehicle when I can afford it as well.
Me, I cycle everywhere. Rarely use. My wife's got a car. We been used that at weekends. I've recently given up meat. That's my
Good
largest,
one. That's a
my
big
largest impact. I think it's the easiest way. Rather than having to change your lifestyle, like get a bike instead of driving a car, probably the easiest way that we can all do something is just to eat less meat. I mean, I haven't gone completely vegan. I love cheese, but I've made a step in the right direction. Right, I've not eaten meat since the beginning of the course and beforehand. So yeah, that can make a big difference without impacting lifestyle. So we can all try that. I suppose. Eat less meat.
Anna?
I have reduced my meat intake and I cycle to work. But my thing that I do is I massively try and reduce food waste. So I literally, anything I buy, anything that's there, I'm going to eat every single part of it and not throw away anything. And people laugh at me because I bring in tiny portions of things, just, well, it's left over, I'm going to eat it.
Yeah, great.
Yeah, I think that's what I need to focus on, yeah. I personally am also vegetarian, but I mean, I'm living in a really poor house, frankly. Sorry if my landlady is watching, but it's not insulated at all. There's no, it's not sustainable in the slightest. So we're all very cold, wearing lots of jumpers because we don't turn the heating on because it costs a lot. But I put in the thread, I think a lot of responsibility around housing should lie with the landlords. And,
yeah, absolutely.
Yeah. So I guess like a big part of that is education as well. So by doing the MOOC, participating in the MOOC, you can make a difference. Spread the word, educate your friends. And we do teaching at the university, so that over our careers, hopefully we have an influence on our students.
And ironically, here in the UK, you can basically get a load of government grants to save yourself money by having your house insulated. Even if you're a landlord, you get the tenant properties you own insulated, and it's going to lower the fuel bills.
But often that's the responsibility of the tenants to pay the fuel bills.
Ah, I see. So that's
there's
taken
no
the incentive.
incentive for the landlords to do it.
We've got a little bit of work to do.
yeah, sadly. It looks like we're going back to the oceans for our next one.
Oh, yeah, we love the ocean.
Has marine life depleted significantly over the past 200 years? And if so, has this affected the oceans, the impact on climate, and has it altered ocean chemistry?
Whoa, you're looking at me, I'm looking at you.
Who wants to take that one?
We've definitely done a massive amount of damage to kind of coastal shelf sea fisheries in lots of parts of the world, and to the whale population, obviously, as well, from whaling. So there are historically some very famous collapses of fish stocks, Newfoundland cod being one of them, but also, in this part of the world, the herring catch around the southwest of England.
Anchovies.
Anchovies. Basically, we still have a situation where offshore kind of bottom trawling fishing is still regularly practiced. So you kind of just scrape up the whole bottom of the shelf sea. That's pretty destructive. So yeah, we've done some disservice to several quite a lot of marine ecosystems to varying degrees. Some of them have kind of collapsed. A few good news stories, a few of them have recovered with the help of establishing marine reserves or changing fisheries policy. As to whether that's changed the chemistry of the ocean, well, there is some really interesting work by colleagues here in biosciences that shows that fish do actually alter the chemistry of the ocean. They kind of have to, in the way that they're drinking salt water. They have to precipitate certain minerals, and those minerals have an effect on the alkalinity and the chemistry of the ocean. So if you kind of eliminate the fish stocks, you will have some probably measurable effect. But we're at such a level of understanding that we're only beginning to think about the role of fish in the ocean, the big picture of ocean chemistry.
One big area that I can think of is the bleaching of coral reefs, which would be kind of extreme temperature events, potentially as a result of climate change.
And they don't like the acidification either, and they don't like nutrient inputs, and so corals often get it on multiple fronts. And of course, corals are typically, if they're healthy, they're very biodiverse, and they're often supporting very healthy fisheries and associated communities. So the general pummeling of coral reefs is bad news for people. certainly for some people more than others. But yeah.
Is there anything we can do to help coral?
Um,
Other than obviously stop us
Well, there's all these crazy ideas to try and reverse ocean acidification by adding lime or crushing up rocks and adding them to the ocean, either via rivers or whatever. But that's an expensive business that requires a lot of energy. There is a whole lot of good work on corals and how we can reduce the multiple stresses on coral reefs. So yeah, I think there's some potential to help, to give them a helping hand. Yeah.
Sounds like they're very sensitive to change.
Yeah, I mean, as you talk to a little bit, they are very sensitive in the sense that Anna mentioned of the bleaching events. Like you can see the reef go kind of literally white and it looks horrific. But some of them bounce back incredibly effectively. Some don't. So that's the funny thing about it. But it would appear that they vary in what ecologists would call their resilience. Some have got more resilience to bounce back from these shock events than others. And that's telling us something about how vulnerable they are in the long term. Yeah.
So we've still got some time left on the feedback video. Keep your questions coming, again, on the hashtag XClimateLive on Twitter. Josh is still monitoring the Facebook pages and the FutureLearn discussion boards, or keep the comments coming on the Google Plus stream to the side as well. Next one, how will climate change affect insurance?
Well, some of the smarter insurance and reinsurance companies are really, really interested in capabilities to both predict extreme weather events and get some sense of how they will change in a changed climate. So they've been trying to develop new, what you might call insurance products to help people cope with changing climate and changing extremes. And then those products sort of vary in their success of uptake usually, even if they seem like very logical products that would benefit people if they took the insurance. People don't always take insurance, and then sometimes they over-insure. So there's a whole melting pot there. But it's a huge area of interest at the moment. And there's a lot of potential that for insurance and reinsurance to help us be a means of managing climate risks. You know, you might take a hit, but if you're insured, you're getting some money back to cope, right? That's the whole point. So insurance, reinsurance is all about redistributing risk. And in that sense, it could be a really powerful part of adaptation if it was done right and it had the uptake. There also might be a way you can use insurance to kind of, in a quirky way, to sort of build money up into a broader global adaptation pot, or into the sort of fund that's going to be needed for developing nations to tackle climate change and to reduce the worst impacts. But that might sound a bit esoteric, but there's quite a lot of thinking going on into how you could use this as a mechanism to, both to redistribute risk and to accumulate kind of the capital you need to respond to bad events.
I'd be concerned that they're trying to make money out of disasters, basically, as a result of climate change.
Well, for the industry to function, they have to turn some kind of profit. That is true, but that's sort of true for everything in the economy. So, at its logical extreme, sometimes obviously free market capitalism has got wildly out of control in some areas, but and indeed insurance and reinsurance industries need to turn a profit to stay in business. So we've got to be a little bit wary of that. But they are really performing a function to redistribute risk or help people manage risk. So that ain't such a bad thing to make your money out of, I think, compared to, say, being a hedge fund investor or something else we might name. So
insurance companies are getting better at it as well. As our understanding of climate change and extreme weather events increases, and insurance companies can weigh up the risks, make it more expensive for particular vulnerable people for insurance, and then maybe even lead to a situation where you have properties just uninsurable, and we start to see managed retreat. It comes into the whole cost-effective side of adaptation or mitigation.
So there's been a key theme around the discussion boards that we haven't really addressed in the feedback video of overpopulation. Is climate change, are we just simply, are there too many people on this planet? Are we just simply consuming too much? And that is the underlying problem in climate change.
Well, the crucial thing is it's not just the number of people, it's population multiplied by consumption level, as you kind of highlighted in the question. And if there is an element of population growth that we can't do anything about, we're probably going to go to 9 billion regardless, because at the moment the global population is skewed in its distribution over age towards younger people. So the young people, well, not that young, but you guys, the girls, can just, all you have to do is get older, and every couple on average have 2 children replacement rate, and we'll get to 9 billion people just by evening out the age distribution. So that's something we've got to learn to cope with. But really, if we look at, say, the last 50 years of data, although there has been obviously some quite striking population growth in the last 50 years, it's actually been the increase in material consumption that has dominated the increase in, for example, greenhouse gas emissions around both fossil fuel use and also the shift towards more meat in the diet and changing agricultural practices. So I would actually, of the two, it's the per capita consumption that trumps the population increase, although they're multiplied together, so they're both contributing to the problem. Yeah, in the long run, who knows what the population will do there? I mean, it will go through 9 billion, it may well go through 10 billion later this century, but pretty much all developed nations have fallen to below replacement rate. In other words, were it not for net immigration, population would tend to be shrinking in many advanced developed nations. So that rather suggests that if we continue a global development program and bring people out of poverty, then we might ultimately have a world in a century or so's time where the global population will start to shrink, which will be good for the Earth to get back into carrying capacity.
And as well, also, it's not just an issue of population, as well as Tim said at the beginning, it's consumption. Like it's uneven in terms of huge countries who are contributing most to emissions. And you, as developed countries, you have to let developing countries the opportunity to develop at a rate which fits their economic growth. So we, as developed countries, need to do more in order to offset this growth. And Pierre Friedrichstein talked about it in his week's content. And you have all this data on countries' emissions, but actually trying to work out like where that's going is difficult. You can say, oh, China's got the most emissions, but actually a lot of that is export. So then that product is going somewhere else. So actually, should those emissions then be placed on the countries where that export is going? So yeah, it's population, but it's also its consumption.
And there is a little bit of good news on the consumption level. Our National Office for National Statistics in the UK has come out with a figure that per capita consumption of all materials has gone down from sort of 15 tonnes per person per year around 2000, I think it was, to around 10 tonnes per person per year now in the UK. So if those figures are right, that's a huge actual decrease in material consumption in the UK, which might have some truth to it. And it's about a shift towards more information technologies, and in fact enjoying smaller and smaller gadgets, and therefore to some degree consuming less material stuff, both in the gadgets and in running them, the energy to run them.
Damien, you kind of touched upon emissions trading and carbon trading just then. Firstly, what is emissions trading, and what's the best way to ensure a robust emissions trading scheme?
Oh, this is falling outside of my expertise, but Tim talked about a little bit about earlier when we have France producing nuclear energy and exporting that electricity to different countries. So they might have a quotation, or a target clean energy. But what countries have started to do is import that clean energy, such as energy that's been generated from a wind farm, put it overseas, then import that and say, oh yeah, we're doing something to combat our emissions. Tim,
I don't have a kind of a detailed, nuanced view exactly on how to run emissions trading schemes, but I am pretty keen on the idea that we set a realistic price on carbon, a so-called social cost of carbon that properly reflects the damages, both overall future time, that we talked about a little bit in the last feedback video, the very long-lived lifetime of carbon dioxide and its effects. And the work I've been doing, putting tipping points into models to assess this, suggests that the real social cost of carbon should be set really high. It should be around $100 per ton of carbon dioxide, or nearly over $400 per ton of carbon. And if you look at any of the actual market carbon prices that have ever been attained, they're at least an order of magnitude below that. So I'm kind of in favour of the policy stick, which is that governments or cohorts of governments, like in the European Union, should actually set a floor on the price of carbon, and they might raise that floor as they become more concerned about climate change over time. But they should set a realistic floor price on carbon that's applied across the board. Now, ironically, it's in the US where they've actually begun to do that in all federal legislation. They have a federally mandated social cost of carbon. It's set too low in my view, but at least it exists. So I would actually roll that out. And yeah, then you can allow some trading of credits or whatever, but actually you've really got to firmly implement, I think, a floor price that you're only ever going to raise on carbon emissions. And we haven't seen the kind of political leadership that would do that yet. So we've got a kind of, for me, a leadership deficit on this crucial issue.
Got some great ones coming in from Carlos on Twitter. Are you optimistic about international agreements on climate change? Are these just words? Are these just documents, or have they actually been put into practice?
We wait with bated breath to see if nations live up to what they would call something like nominal, their INDCs, their sort of voluntary offers of reducing carbon emissions. Will they actually legislate to achieve those goals?
This is at the Paris conference.
Yeah, the Paris conference. I'm afraid a little bit sceptical that they will, but I'm encouraged that in the UK we have a Climate Change Act, so we have enshrined into law essentially a target to reduce carbon or greenhouse gas emissions by something like 80% by 2050, which is a stunningly difficult target. We've made some progress towards it. We've done all the easy things, and now we're stuck with starting to have to do the difficult things. Unfortunately, here in the UK, we have a government that's backpedaling on this stuff and not properly kind of seeing through on that. So we need to, as voters, we ought to be applying some pressure on that topic. The general backstory is we've had some great successes in environmental legislation in the past, but we've never had an environmental problem that was so hard to tackle and so entwined in how the whole global economy runs, fueled by fossil fuels. So that's why many of us are worried and a little bit doubtful about the scale and rapidity of action. Again, I come back to political leadership. It could happen, but it will require really strong leadership. It's not that the entrepreneurs in the economy don't want it to happen. In fact, they'd be delighted to start to make the transition, a lot of them, if they just had some clear signals from government.
Anna, are you optimistic?
Well, I don't know. A lot of these changes are supposed to be enforced and completely in practice by 2050. I'm going to be there, so I'm excited to find out, but skeptical. I'm a naturally skeptical person.
You must be a scientist.
The thing is, like, we've shown over the course that action is going to have to be unprecedented. Like, we're going to have to respond to this globally, and in order to make a real difference, it's going to have to be unprecedented action. I guess we can take optimism because we've not done anything about it yet. We've not even started.
Scratch the surface.
Yeah. So let's start making a change, and let's start doing something about it, and let's make it happen. But based on what we're doing now, it's not going to happen. But we need to start. That's why we can be optimistic, because we haven't started yet. Really.
The gulf between words and action is considerable. Yeah.
So I guess just to wrap this up with one final question: what do you want learners to take from the MOOC? What if you had to pick one thing? What do you want them to? What's like take-home messages from the course?
I actually want learners to be kind of feel a certain thrill and reverence for this extraordinary planet we live on, and the fact just to sort of marvel at how we're here in the first place. And we are like only here because nearly 4 billion years of life has created a habitable environment for us, and the Earth as a system has weathered the storm of a brightening sun and snowball Earth and you name it. So we need to kind of remember the miracle of our own existence and actually cherish this world we're on. And from that perspective of kind of celebration almost, we ought to be rightly disgraced at what our species is doing collectively to kind of mess up this extraordinary product of evolution. But then we need to remember, like I maybe said in the last feedback video, that everything that's gone on to change the world has started with some individual organism somewhere in some corner of the planet. So we have got the power to make a difference. And who's to say which things we do or which innovations won't spread and really help make this a kind of what people are beginning to call a good Anthropocene rather than a sort of a bleak Anthropocene. That's what we need to do. We need to get a collective brain together and decide on a good Anthropocene and go on that journey together.
Wow, what a humbling review.
That's my just a small one.
Yeah, add to that, I think hopefully you've learned something on this course. You can take that with you, and we can hopefully move on from this climate change debate and actually start talking about climate action. How we're gonna respond to this, how we're gonna make a difference. So move on from climate change and start towards climate action.
Anna, what's your take-home message?
Well, I think it's great that so many people have said that they're going to take this into their classroom, to take it into their home, their community. So that's wonderful. So many people signed up and they're going to do something themselves. So that's my take-home message.
I guess when I started the course, I wanted people to hear the stories from around the world. So throughout the discussion boards, we've seen sort of how drought is affecting certain people, how acidification is affecting certain people, ice is affecting others. So my take-home message is probably something around a global community. Like you said in the video, think global, act local.
Yeah, we've made
that's a good take.
And the course has helped make it personal, which is great. We've connected from around the world, and we're in this together, and we can get through this into a better place together. Fantastic.
Tim or Damien, do you want to say something to end the MOOC?
That'll do as my parting note. Thanks so much to everyone who's participated and just joined us online this hour. Thanks to Liam for chairing us so expertly.
And Josh behind the scenes, of course.
Josh
and Kelly, who's helping make this happen.
Yeah.
Thank you very much for joining us.